All right, so now we are in the Unit 3, Lesson 5, Transversal Proofs Part 2 homework. Some people asked for a few videos here, so let's start with number 7. Okay, so in 7, I'm given two things. I'm told A is parallel to B, and I'm told that A is parallel to C. And some of you might be thinking, well, if A is parallel to B and A is parallel to C, then B is parallel to C. It's just transitive. But the problem is we've never applied transitivity to parallel lines before. It's not it seems like it should work, but we haven't proven it. So this is really where we're going to prove it. And now after this, we kind of know that this will work, that anytime we have one set of lines that are parallel and another set of lines that are parallel, and one of those in each set is a common line, then we'll know all the lines are parallel. But this is basically like proving a theorem. All right, so I set up my statements and reasons, I write down my givens, and I make my plan. All right, so I look over here and I say, well, I got some numbered angles. How could I use those? Well, hopefully you realize that based on A being parallel to B, I can say that angles 1 and 2 are congruent. And that's directly from the corresponding angles postulate. And because A is parallel to C, I know that angle 1 and angle 3 are congruent. So because I know that 2 is congruent to 1 and 1 is congruent to 3, I know that 2 is congruent to 3. Now that's transitive, but it's a different kind of transitive. It's a transitive when it comes to angle equality, which is something, or angle congruence, which are areas where we've applied transitivity in the past, and we've said we can assume transitivity works in those situations. So how do I actually write my proof? Well, I'm going to start with angle 1 is congruent to angle 2, and that's because of the corresponding angles postulate. It's not a converse. I'm saying something about angles, not something about lines, so it's just the regular old postulate. I also want to say 1 is congruent to 3, like so. And again, that's also the corresponding angles postulate, because 1 and 3 are corresponding angles, and the postulate says that if lines are parallel, then corresponding angles are congruent. That takes me over to my transition, which is, well, if 1's congruent to 2 and 1's congruent to 3, then 2's congruent to 3. That's transitivity. And then I think, well, how does that help me? Well, remember, if corresponding angles are congruent, and 2 and 3 are, then the lines are parallel. So kind of thinking through how we've analyzed this in the past, we said, well, this line that connects the two vertices must be the transversal. These are the other two sides of those angles. So in this situation, these two sides must be parallel. B is parallel to C. And hopefully you're thinking to yourself, well, I just proved something parallel using the angles, so that's a converse. It's not one of our forward postulates or theorems. It's one of the converse postulates or theorems. And what relationship do 2 and 3 have? They're corresponding angles. Hope that helps.